Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 8.1, Problem 3. This is Section 8.1, Problem number 3. It says people's total cholesterol is normally distributed with a mean of 186 and a standard deviation of 24. What is the probability that a randomly selected person has a total cholesterol of over 200? So just one person. This isn't a sample of a group of people like parts B, C, and D. This is just one person. So I can't look up a 200 cholesterol level in the chart that I want to use. And again, we use that z-score chart because the question says normally distributed. So I want to do z equals x minus the mean over the standard deviation. So z equals x, the number we want to find the z-score for is 200, minus the mean or average value is 186, divided by the standard deviation. So for the whole population, so you're going to take one person at a time, it would be 24. So now do the math. You would have 200 minus 186 would be 14, and you have 24 underneath. You can reduce that, but you can just go right ahead to the calculator and do 14 divided by 24 equals, and see what you get. So 14 divided by 24, the answer is 0.5833333. The 3's go to the end of the calculator screen. So the notation for a digit that keeps repeating after the decimal like that, you just put a bar over it instead of writing all those 3's. So 0.58 repeating 3 is what I want to look up. So there's a 4-step process to look this up. Step 1, write the number to look up so that it has 2 places after the decimal. So the 3's aren't quite big enough to make it a 0.59. So I'm just going to chop it at 0.58. That's step 1, write the number to look up so that it has 2 places after the decimal. It is now written so that it has 2 places after the decimal. Step 2, split the number into 2 parts by pulling off the rightmost digit. So that 8's going to come off to the side. Next, put a 0.0 in front of the rightmost digit that you pulled off. So instead of 8, it's 0.08. Now what we do is we go to the chart, we go to the positive 0.5 row, the 0.8 column, and we see where that positive 0.5 row and the 0.08 column intersect. They intersect at 0.7190. So now that's what the chart says, but that may or may not be the final answer. If the question says less than, that's the final answer. If the question says greater than, we have to do 1 minus the chart value. So when I go back to the question and it says what's the probability that a person has a cholesterol level of over 200, that's a greater than. So I have to do 1 minus the chart value. If it was less than 200, we'd be done with the 7190. But because it says over, I have to do 1 minus the chart value. So 1 minus 0.7190 would be 0.2810. About a 28% probability that any one randomly selected person would have a cholesterol level of over 200. So B says, what's the probability that a random sample of 9 people has a mean cholesterol of over 200. So you randomly select 9 people, find the cholesterol of all 9 averages together. What's the probability that that average of the 9 people is over 200? It's a very similar process. The difference is the denominator. So I'll make a little room. And I'll start with my z-score formula. I need to find the z-score for a mean cholesterol of over 200 for a random sample of 9 people. So as I fill in my z-score formula, z equals x, the number I want to find the z-score for is still 200. Minus the mean. Well, the mean of many samples of 9 people is going to be the same as the mean of the population in general at 186. The standard deviation, though, is a little different. The standard deviation for the whole population taken one at a time is 24. So in other words, on average, from one person to the next, the difference in their cholesterol level is 24 points. But from one sample of 9 people to the next, the average of those 9 is going to be less spread out than the 24. And what it's going to be is going to be the 24 for the population over the square root of the sample size, which for part B, I have 9 people. And what you see is in every next part, that sample size is going to get a little bit bigger. And you'll see what that does to the probability. So for part B, the size of the sample is 9. So now on top, 200 minus 186 is 14. The denominator, 24 over square root of 9, I can write as 24 over 3. Right? Square root of 9 is 3. 3 times 3 is 9. And I can simplify the denominator a little bit more. 24 over 3 can be reduced to 8. So now this is what I have to look up, 14 over 8. You can reduce that, or you can just go right to your calculator. 14 divided by 8 equals. So 14 divided by 8 is 1.75. That's my z-score. 1.75 is what I need to look up in the standard normal chart. So to look up anything in the chart, step 1, write the number to look up so that it has 2 places after the decimal. It already has 2 places after the decimal. That step's easy. Step 2, split the number into 2 parts by pulling off the rightmost digit. So that 5 is going to come off to the side. The next step, you put a 0.0 in front of the rightmost digit that you pulled off. So instead of just a 5, it's a 0.05. And now you go to that chart. You go to the 1.7 row, positive 1.7. Follow it out until you're under the 0.05 column. And you'll see that row of 1.7 and the column of 0.05 will intersect at 0.9599. That's the value from the chart. Now again, that may or may not be my final answer. We have to go back to the original question and pay attention to whether it says less than or greater than. If it's less than, the 9599 is the final answer. If it's greater than, it's 1 minus the 9599. And as I look over 200, that is a greater than. The question essentially says, what's the probability that the average of 9 people has a mean cholesterol of greater than 200, over 200, greater than 200. So I have to do 1 minus the chart value. 1 minus 0.9599 is 0.0401. So the answer to part B is 0.0401. It's about a 4% probability that if you randomly choose a group of 9 people and find the average of their cholesterol levels, that average comes out to over 200. It's about a 4% chance, compared to a 28% chance of any one single individual person having a cholesterol of over 200. So part C, basically, they just want a bigger sample size. For B, they said, what is the probability that a random sample of 9 people has a mean cholesterol of over 200? C is, what is the probability a random sample of 16 people has a mean cholesterol of over 200? Same question, just with a bigger sample. And we'll see what that does to the probability. As we make the sample bigger, getting away from the average value should be less likely. That's what you can expect. Let's see if that actually happens. Again, I'll make a little room right next to where I did. I'll leave the z-score formula and I'll fill it in. It's going to fill in almost the same. The only thing really that's going to change is the denominator here. So in fact, let's leave the next line too. So again, I need to find the z-score for a sample of 16 having an average cholesterol of over 200. Same z-score formula, x, the number I'm converting, is still 200 for part C, minus the mean. So if you take many samples of 16, the mean of the samples would tend to be the same as the mean of the whole population. It's still 186. But now the standard deviation for samples of 16, it wouldn't be 24 over square root of 9 anymore. What changes for part C is over the square root of 16. So it's the standard deviation for the overall population over the square root of the size of the sample. And that's really all that changes from part B to part C. Sample size of 9 goes up to a sample size of 16. A little bigger sample makes it less likely to get too far away from the population average, we'll see. Let's start doing the math. So again, on top, 200 minus 186, positive 14. Denominator will be 24 over square root of 16 is 4, because 4 times 4 is 16. And I can reduce that without a calculator. The 14 on top, 24 divided by 4 is 6. I can even reduce that. You can simplify it a little bit, but you can just go right to your calculator at this point. 14 divided by 6 equals, should be 2 1/3. And it is. The calculator says 2.333333. The 3's go off to the end of the screen. And again, the notation for that, you can write many, many 3's, but the notation really, what's easier is just put the first thing that repeats and put a bar over it. So that's what I want to look up, 2.333333. Step 1, write the number to look up so that it has 2 places after the decimal. So I'll put the first 2 3's. The next one out would not be big enough to make it a 2.34. So the number to look up written so that it has 2 places after the decimal is 2.33. The next step after that is split the number into 2 parts by pulling off the rightmost digit. So I have 2.3. The last 3 comes off to the side. The next step is put a 0.0 in front of the rightmost digit that you pulled off. So instead of a 3, it's a 0.03. Now we'll go to that standard normal chart. Again, pay attention to positive and negative. This is a positive 2.3 row. And we'll follow it out until we are under the 0, 3 column. And those will intersect at 0.9901. Now again, this may or may not be my final answer, the 0.9901, and like the previous parts, it's not. The question says over 200, essentially it's a greater than. If it had been a less than 200, 9901 would be my final answer. Because it's a greater than, I have to do 1 minus the chart value, 1 minus 0.9901, which is 0.0099. With some type of sensible round off, it's a 1% probability. So you can see any one person having a cholesterol level of over 200, 28% chance. A sample of 9 people having an average cholesterol over 200 drops down to 4%. So as you go from a 9-person sample size to a 16-person sample size, goes from 4% to about 1%. Now let's make it a little bigger still. Instead of 16 people in the sample, let's bump it up to 36 and see what that does to the probability. And again, it should get even less likely. The bigger the sample is, the less likely it is to get further away from the population mean. So what is the probability that a random sample of 36 people has a mean cholesterol of over 200? So, same process. I'll leave the top line, which is my z-score formula. I'll even leave the second line, and it's underneath that the things change enough that I'll just make some room. So I'll get rid of the value under the square root, which is the sample size. So as I do the work for part D, I want to fill in x minus the mean over the standard deviation. The x, the number I want my z-score for, is still 200. That can stay. The minus can stay. The mean, again, can stay, 186. So if you take enough samples of 36 people, the average of those means would average out to the same as the average of the population, which is 186. It's the standard deviation, or the measure of how spread out those samples of 36 people would be. So the 24 is still in the numerator, the standard deviation of the population. But in the denominator, it's the square root of the sample size. So for part D, we have a sample size of 36. So that's how it fills in. So let's start the math. On top, 200 minus 186 is 14. In the denominator, I would have 24 over 6, because square root of 36 is 6. 6 times 6 is 36. Now I would have 14 over 24 divided by 6. I can do without a calculator is 4. Right? 24 divided by 6 is 4. Even 14 over 4, I can do comfortably enough without a calculator. It's 3.5. If you're not sure, with your calculator, 14 divided by 4 equals, and your calculator will say 3.5. So this is what I want to look up. So step 1, write the number to look up so that it has 2 places after the decimal. The 3.5 would get written as 3.50. The next step, split that number into 2 parts by pulling the rightmost digit off. So the 0 we just put on, we pull it off to the side. The next step is you put a point 0 in front of the rightmost digit that you just pulled off. It's written as 0.00. So now I go to the positive 3.5 row and the 0, 0 column, see where they intersect. Now when you look for that, you'll see that there is no 3.5 row. It goes up to 3.4. There's a little note at the bottom. For values of 3.5 and bigger, assume that the answer is 1. So we've gone off the chart. Now again, if the question asks less than, the answer would be 1 or 100% chance. But because it's a greater than over 200, it's 1 minus the chart value. Anything past 3.5, the answer from the chart is 1. So it would be 1 minus the chart value, 1 minus 1. The probability is essentially 0. It's not truly 0, but within round off beyond 4 places after the decimal, it's 0. The first 4 or more digits would be 0. So the probability of having a sample of 36 people have their average cholesterol over 200 would be very close to impossible.